Okay, I think the last function which we were actually about to do was your I function. Okay, and we were not able to complete it. Now, this function is available in the package in the library uh, under the package NumPy, under the library or module, you can call it as Matplotlib or matrix library. Okay, what it does is it adds a, you can say, stores one along the diagonal of a matrix. So diagonal elements, all diagonal elements will have value 1, whereas the non-diagonal elements will store zeros in it. Okay, that is what this function does. To take an example, I have imported the NumPy package and the module under NumPy matrix library, that is MATLIB. Okay, the function syntax, it takes 4 parameters. So let us see all the 4 parameters. What I'll do is I'll directly print it. So let me give print np.matlib into round bracket, dot I into round brackets. Now, the first parameter is the value of n, that is the number of rows in the output, whereas the second parameter m is optional. If I do not pass the value of m, that is number of columns, then by default it is going to consider n as the default value. Yes, Advait?
So can you please repeat? Actually, no, I lost a bit of networks.
Okay. Uh, Today, the function which we are going to do is the I function, which is a part of your module matrix library, that is Matplotlib, LIB. Okay, it takes 4 parameters. The first parameter is the number of rows. Okay, second parameter is number of columns, which is optional. If I do not pass the value of the number of columns for this particular function, it is going to consider n, the number of rows, as the value for the number of columns as well. Okay, the purpose of this function is to put or assign 1 along the diagonal elements and zeros elsewhere. Clear? The the third parameter, that is the value of k, is again integer, which is optional. It indicates the index position or the element position from where I want the value to be 1. Okay, and the last parameter is the data type, which we can provide using dtype. So let us create a matrix which is having, say, 3 rows. Okay, I'll pass the value for m, and please remember it is capital M. So if I want, say, 4 columns, okay, the value of k by default is always 0. I'll assign 0 right now, and d type, I'll keep it as float. Okay, let us run this one and check the output. Okay, here you can see this now. At index position 0, my number 1, and this is my diagonal. This is not a square matrix. What is happening is, here the last value, okay, is kept 0 here. Okay, only along the diagonal, depending on the value of k. Now, if I change the value of k to 1, okay, and then run this, you can see this 1 has changed to column number 1, this one. So from here, I'll get 1 and the diagonal form. Okay, if I do not pass the value for n, so if I delete this, okay, and k by default, as you said, is 0, so I keep this as 0 here. Now when I run this, now because I have not passed the value of capital M, your matrix is a square matrix where the number of rows and columns are equal to 3. Clear? The matrix, see, there are many calculations where we need to have a matrix which has ones in the diagonal. Okay, your identity matrix, then your square matrix, then matrix having zeros in it. Okay, might be you'll require such types of matrices when you need to do some calculations. Okay, so this will be my default matrix. So depends on what calculations what you are actually trying to do. Fine. Now there's one more, you can say, function called identity, which gives returns the identity matrix of the given size which we are going to mention. Now, an identity matrix is a square matrix with all the diagonal elements as one. Okay. Now, there is a difference between the I function and the identity function. The identity function will, by default, will have a square matrix. That means the number of rows and number of columns will be same. Whereas in case of the I function, we have an option of giving the dimension, the number of rows and the columns. Plus, we also have an option of from where I want the value 1 to be inserted and in the diagonal form. That's the difference. So if I, instead of using the I function, if I give print np.matlib.identity, okay, and it takes only two parameters here. The first parameter will be the size, the dimension. So let me give a size of 5. That is the value of n. And if I want, you can also mention your data type. So your data type I am keeping as float. Okay. Now when I run this one, here you can see I have got a 5 by 5 matrix, and all the diagonal values are your ones. Okay. And non-diagonal values are zeros. Clear? So these are some functions which are available that can help me in handling matrices. The other function where if I want to have random values, if I want my elements to have some random values in it, then there is a function called RAND, okay, which gives me the random numbers are assigned in my elements in the matrix. For that function, again, I'll give a print statement here. So print np dot matlib dot random rand and the dimension. Now, if I want to, let us say 3, comma, say 3. Okay, and when I run this one, here you can see I got a 3 by 3 matrix, and these are my random numbers which are assigned to it. Okay, so you can also create a matrix which is having random numbers in it. Now there is a difference, minor difference between an array and a matrix. Okay, the difference is that the matrix is always a two-dimensional form of an array. Okay, and there's the reason why if I have a 2D array, I can easily convert the 2D array into a matrix, or a matrix can be easily converted into an array. Whereas if you look at arrays can be of n dimension. There is no limit there. Okay, I can have 3 dimension, 4 dimension, and so on. Whereas matrix cannot be 3D. Okay, it cannot be a 3-dimension matrix. That's the major difference between the matrix and your array. Clear? Can we use d type equal to n random? Let us use it, because I have not tried it. As per the, you can see the dimension which was mentioned. So if I give a comma, there's no return a matrix of random numbers. No, by default it is you can say float. Let me try giving it. If it works out, fine, but because it's already float, I don't think so there should be any issues. Okay, so here you can see it's not supported. Okay, by default it is float. Okay, and always remember when you're trying to give parameters, whenever we try to give the arguments, you'll get a pop-up which indicates how many maximum parameters can be passed to that particular function. Okay, so by default, we have by default the data type is float, and we need to pass the number of rows and the number of columns as the two arguments. Okay, and as I told you, we can convert a matrix into an array, or an array which is by default, if it is a 2D array, into a matrix. Now to show you that example, let us create one matrix. So I can give I equal to np dot matrix, and in the round brackets I'll pass the values. So I can give you in, say, the data values, say 1 comma 2, put a semicolon to indicate the end of that particular row, and 3 comma 4. Okay, and let us print this value I. Okay, so here you can see 1 2 and 3 4 is my new matrix. Now if I want to convert this into an array, let us put it in J. So I'll write J equal to np dot as array. This is my function which can help me convert the input, whatever I pass here. Now I am going to pass I because that is the matrix which I have created, and I'll convert that into an array and store it in J. So let us print J here. Okay, here we go. So this is your matrix and this is my array. I can do the similar thing. I can convert my array into a matrix. So if I have an array, let us say, let me create another one, A equal to np dot, let us use arrange, and let us give 9 dot reshape, and 3 comma 3. Okay, so this is my 2D array, and now I can have, let us say, I have k here, k equal to np dot as matrix, and into bracket I can pass the array. Okay, and will display print k. Okay, it is one and the same thing. So here we go. Here is my matrix now, and it is a 2D one. Okay, any doubts here? Can we use transpose in matrix? No, transpose is a function of an array. What you can do is, if you want to do transpose, convert that into an array, transpose it, and convert back into a matrix. Okay, so if there are some functions which are supported by, you can say, the array functions which are available in ND array, make use of those functions, and you can easily convert that whole thing into a matrix later on. Okay, it's like interchangeable. So these are some common functions which are available under matrix. Fine. Let us create a new file, and let us go to the next topic, which is linear algebra. So if I need to use functions like determinant, and you can say variant, and matrix multiplications, all this, if I want to perform this, now I can make use of some the functions which are available under the module linear algebra. Okay, your linear algebra, there are different equations which are available, okay, that can also be used to do the calculations. So for example, if suppose I have to multiply two matrices, okay, so product of two matrices or two vectors or two arrays, okay, we can make use of some functions. Let us go ahead and see those functions. First of all, there's a package under NumPy. There's a module by the name linear algebra, LINALG, which is the shortcut for the name linear algebra. Okay, this module provides all the functionalities uh, required for linear algebra. So let me first of all import this module from NumPy. So I have NumPy dot Matlab. Okay, this is my module. I'll also import NumPy as NP so that we can make use of this NP. Now, the first function which we will take is the dot function. The dot function actually finds the product of two arrays. Okay, so if you have a 2D vector, it is like equivalent to your matrix multiplication. Okay, if you remember the rules for matrix multiplication, the number of columns of the first matrix, okay, should be equal to the number of columns. Sorry, the number of columns of the first matrix should be equal to the number of rows of the second matrix. Only then multiplication is possible. And the multiplication happens, so, row is multiplied by the column and so on. Okay, that is what I want to say when I'm referring to matrix multiplication. Okay, if I have a 1D array, okay, then it finds the inner product of the vector. Okay, and for your n-dimensional array, if I have an n-dimensional array, a 3D array or 4D array, then it is the sum product over the last axis of the first matrix or the first array and the second last axis of the second array. So if I take the first array to be say A, then it is the sum product over the last axis of A and the second last axis of B. Okay. Now you won't understand here directly when we take an example. Let us try to take an example and check how it works out. So first function which I'll take is the dot function. For that, I need an array. So I'll create an array A equal to np dot array. And let us create a 2D array here with values 1, 2, and 3, 4. Okay, I'll have another matrix or array so that we can perform the multiplication, the product np dot array. Let us have say something wrong. Yeah. I'll have 11, say 12, and one more 13, 14. Okay, so this I can directly print. See np dot. The function name is also dot into bracket a comma b. So here, because it's a 2D array, it's going to perform matrix multiplication, and your output looks like this. You can perform the multiplication and check it out whether it is really as per what we thought of. Okay, please, if you want, you can also check the multiplication and check it out. Okay, that is your output for your matrix multiplication, which is a 2D array. Then there's another function which is, you can say, a pair of dot function, which is v dot. Okay, and it is especially meant for two vectors. Okay, suppose if I have two vectors, I can easily make use of this function. Now, how it works? Let us take an example. Okay, just 1 minute. Yeah. So if I'll continue with the same array, that is A and B, okay, and try to make use of this function v dot. Now, if the first argument, the use of v dot is especially when we have complex values. Okay, if there is a complex value given as a parameter for your vector array, then the conjugate is considered while doing the calculation for your matrices, okay, or your four vectors. Now, if the argument ID is a multi-dimensional array, what is going to happen? It is going to flatten the array and then perform the multiplication. Clear? So I can just change this to v dot like this. So this is another function which can also give me, so where it is performing not a matrix multiplication, it's performing all the multiplication and I get the product as 130. If you want, you can do the calculation, add it up, and the total, the product of the two vectors will come to 130. Clear? So dot and v dot, these are two functions. Dot will perform matrix multiplication and v dot will perform the multiplication and give me the value. And as I told you, if it is n dimension, it is going to convert it into a 1D, that is, it is going to flatten it and then perform the calculation. Now, the other function which is available is the inner function, wherein the inner function finds the product of the vectors for 1D array. Okay, and for higher dimension, it returns the sum product over the last axis. Okay, that means even if it is a 2D array, it is not going to perform a multiplication, the matrix multiplication which we saw. It is going to multiply the first row with the first column and give its product. Okay, so it is always a row into row. And if it is a matrix multiplication using dot, that is row multiplied by the column. Okay, that's the difference between inner and your dot function. Let us see this example where we can multiply. Let me use print here, np dot, in this I'm going to have an array. Let us have an array here, a 2D array, or we can have a 1D array and finish it off. Let me create it here itself, np dot array. I can pass the parameter here also while creating it. So I'll create a 1D array here, 1, 2, let us say 3. Okay, and I come here, pass comma, and the second array which I want to pass can come here, np dot array. Let us give some values, and it has to be 3 columns. So 3 values I have to give, and it is a 1D array, so I can give 0, 1, 0. And let us run this one. Okay, that's the answer I'm getting, because you can see anything 1 multiplied by 0 plus 2 multiplied by 1 plus 3 multiplied by 0. So the answer comes to 2. It's that simple. Okay, now if suppose I have a, we can say, a multiple dimension or 2D array. Okay, now how that is going to work out if I'm using the inner function here. So this was the example of a 1D array. Let us take the 2D array A and B. np dot inner into bracket, I can give A comma B. Okay, now what is going to happen is if you look at this array here, it is going to take 1 multiplied by 11, right, plus 2 multiplied by 12. Okay, that is going to give me the first value. Next, again, it will take the first row, that is 1, 2, multiply by the second row, 13 and you can say 14. Okay, so 1 multiplied by 13 plus 2 multiplied by 14. That is what the resultant row, the first row will be. Then it will take the second row, multiply by the first row, get me the first element of the second row. And then again, the second row multiplied by the second column will give me the last element of your 2D array. Let us see how the results are displayed. So here we go, we have 35 for the first element. So that is 1 multiplied by 11 plus that is 11, and 2 multiplied by 12, that is 24, that gives me 35. Okay, that's how we got this 35 here. Whereas if you saw the previous multiplication using dot, okay, we had got 37 there. Okay, so there's a difference between both of them. The inner function is going to just take the first row, multiply the first row. So it is like a row multiplications. Okay. Now there's one more function which is not a part of your Matlab, but a part of your NumPy itself. okay, where we can make use of mat multiplication, MATMUL. That is the function which can also perform matrix multiplication. Okay, so to take that example, I'll create another a equal to, let us write, I'll create the 1 comma 0, so it becomes easy to do the check the values, and 0 comma 1. Okay, let us see, this is my 2 rows and 2 columns, and I have B. Again, I can give, say, 4 comma 1 and 2 comma, let us give comma 2. Okay, and as I told you, the first rule is the number of columns should be equal to number of rows of the second array. Only then matrix multiplication will be possible. And the function, instead of using the matlib function, I can use it directly np.matmul. That is matrix multiplication. Okay, it gives you, it takes you 2 parameters. Let us give a comma b. Okay, and now run this. Here we go. That's the multiplication result which I've got for this 2D array. If you want, you can just carry out the multiplication and check it out on your own. Now, the advantage of this mat mul is that if suppose I have a 1D array in, let us say the first one is a 2D array. Okay, and let me remove this. So I don't want the second row. I want only one row where the multiplication will be possible. Now, what is the rule? As I said, let us take this 1 and 2. The number of columns of the first matrix should be equal to the number of columns of the rows of the second matrix. And now, if you follow that rule, okay, and do the multiplication, whether it is going to multiply. In this case, if I have follow the rule there, it is not going to. So what happens is, especially in Python, your second array, which is having only one row, will be broadcasted. Okay, and one more row will be added with the same value 1 comma 2, and it is going to perform the multiplication. So if I can multiply this, let us see this. We'll use a comma b and b comma a also. Here you can see I got 1 comma this, and if I multiply the other way around, if I say b comma a, okay, and then perform the multiplication, here we go, hardly any difference. Okay, that's the result. So one array having a, you can say, if have a mixed dimension with 1D, okay, the resultant is always the 1D array, not like the regular matrix which we get. So depending on the second matrix, usually you get the dimension, which is not happening here. Okay. One more thing, if I have an array having a dimension more than 2, okay, then what happens is it is going to multiply it, but it will create, you can say, 2D arrays of multiple dimensions, you can say. Let us create one 3D array and a 2D array and try to multiply it using this mat mul function. So if suppose, let me change this one. Let me create an array A using A arrange, and let us have some value, let us 8, and reshape this. Say I'll make it a 3D array, so 2 comma 2 comma 2. Okay, so that means I have two two-dimensional arrays, you can say, which is having 2 rows and 2 columns. That is what this actually dimension means. And when I say b equal to, I'll here create a 2D array. Again, let me use arrange, and this time I'll use 4, and reshape this to 2 comma 2. Okay. Now what you can do is, when you're practicing it out, try with the different dimensions and check how it works out. Okay, so I can just take, I'm taking just a single example here. So matrix multiplication function, into round brackets I pass a comma b. Okay, so let me comment all this, the upper ones. Here we go. And now run this. Here we go. You can see this 2D array here and a 2D array. So two 2D arrays. As I told you, the dimension, because it's a 3D array, it says that I have two 2D arrays. Okay, and it performs the multiplication as per the values. So the first, you can say the value of B will be first multiplied for the first 2D array, and then the same one will be multiplied with the second one. Okay, that is how it works. Clear? So these are some functions which are used for matrix and matrix multiplications under algebra, linear algebra. Now, when we talk about linear algebra, the first thing that comes to your mind is determinant. Okay, so if I want to find determinant of a particular matrix, okay, I have to just make use of a simple function. Let us take an example here. I'm going to delete all this. Okay, and instead of now Matplotlib, let me input a function, or let us directly try it out here. I'll create an array a equal to np dot array, and it will be a 2D array. So let me pass 1, 2 and 3, 4. This could have been also done with using the range function and the combination of reshape function. Okay, this is simple. We can give just print np dot l I n alg. This is your linear algebra. Okay, LIN linear ALG algebra. Under this, there is a function called DET for your determinant. So for determinant of an array, the name of the array is A here. There's no other parameter. Let us run this one. Okay, and this is my answer, minus 2.000. That is the answer for the determinant of the given matrix. Okay, how do you find the determinant? Let us take some other example. This is a 2D array. Let us create 3 rows and 3 columns with the different values in it. So np dot array. Let us take some different varieties of values. One. Okay, so I have one array here with 3 rows and 3 columns. Let us take some negative value. Okay, and one more last row. I get 2, 8, 7. Okay, so this is my array. Now, if I want to find the determinant of this, okay, let us print this. I'll just try to explain you how the determinant is calculated. If possible, let us check it out. Yes. Okay, what happens in this? 6 will be taken outside. So 6 multiplied by into round brackets this innermost. So you have to ignore this row and this column. So minus 2 multiplied by cross multiplication we do. Minus 2 multiplied by 7 minus 5 multiplied by 8. Okay, so this gives me one value. Then take this number, which will be minus 1. You have to take the middle value is always minus, the second value, minus 1, into round brackets. Now, do not consider this column and this row. 4 multiplied by 7 minus 5 multiplied by 2. Again, plus 1. Now, this time it will be 1 plus 1. Do not consider this column and this row. Cross multiply 4 by 8 minus into bracket, you can say minus 2 into 2. If you add this up, all of the 3 values, you'll get the result. Okay, so let us see what actually result comes here. So if I am finding it out, let us print determinant of B. Okay, and I'll print it np dot Linalg, that is your linear algebra, dot the determined function det into bracket b. Okay, now run this, and that's my answer, minus 306.0. If you want, please go ahead and do the calculation and check for yourself. Clear? Now, there are other equations, linear equations also, which are available, and we can solve those equations as well. Okay, like for example, if I have x plus y plus z, or z equal to 6, then there's another function, let us say 2y plus 5z equal to minus 4, and 2x plus 5y minus z equal to 27, and I want to find the solution for this linear equations. Then there's a function called solve. Okay, the solve function gives the solution for the linear equation in the matrix form. Right? So when we come next, we will try this functions, especially solve, and we'll also check a function called inverse, which gives me the inverse of a matrix. Okay, and we'll check how to solve some of the linear equations. Okay, we have some around, I think, 4 minutes. I won't be able to complete that example in that short period of time. Now, I can take one simple function, the inverse function. So if I have a matrix here, say, let us say I want to inverse the matrix A here. Okay, so it is a very simple function. I can say y equal to, let us inverse and save it in np dot. It is a part of linear algebra. So linear algebra dot inv is the function for the inverse. Let us pass A. So it is going to inverse the array A, and I'll print both A and print Y as well. Okay, so, and check the output. What happened? Okay, P is capital here. As you know, case sensitive, so P small. Here we go. So this is my original array A, where we had 1, 2, 3, 4. And the inverse of this matrix is given here. So minus 2, 1, 1.5, and minus 0.5. Okay, that's the inverse of your matrix A. Right, so when we come next, as I told you, we'll solve some, I think 1 or 2 problems are there. Basically the solve function, and we'll also see the dot function again, where if I multiply the two inverse values, let us say if I want to say print np dot, again dot function into bracket a comma y. Okay, so I'm multiplying, the two values, the original value with this inverse of it. Okay, that's, it gives you me this value. You can see this one. Okay. So you'll find some problems where you have to find the inverse of the matrix, and use the identity matrix, and do perform some multiplications, matrix multiplication, inner multiplication. So please remember which function to make use of. And these are some, you can say, functions which will be used more for scientific calculations, or you can say where we have researchers or we have algorithms. And why we are doing this here is because when we go ahead, we might come across some algorithm where we might be using the matrices and all. Clear? So we'll stop here today. And when we come next, we will solve some graphs. We'll check this package or the library for plotting graphs in Python, that is Matplotlib. Okay, there's a, you can see, library for your graphs, which is just an alternative for your MATLAB. Okay, MATLAB, which was originally supported before, and it was very famous. Now in Python, we have an option of that is Matplotlib, which can be used to do all the types of graphs which are possible. So we'll take some examples when we come next. Okay, so thank you everyone. See you in the next session. Bye.